everyone. I am Neha from DS2A section. My assignment topic is Web-based visualizer for structural representation of C program. Introduction. Compiler design is an important subject in computer science that focuses on converting high-level programming languages into machine-readable instructions. Today, AI-based coding assistants such as ChatGPT, GitHub help programmers write, debug, and optimize code. This system do not treat source code as ordinary text. Objectives: develop a web-based visualizer tool. Create an interactive web application that accepts a simple C program and displays their internal representation in an easy to understand format. Generate an ATC. Build and visualize an abstract syntax tree to represent the hierarchical structure of the program. Improve program understanding. Provides visual representation that makes program structure, execution, flow, and data relationships easier to understand. Problem statement. In modern software development, understanding source code requires more than simply reading text. Compilers and AI coding assistant analyze program at multiple levels to understand their structure, behavior, and dependencies. However, students often find it difficult to visualize the internal representation because they are not directly visible during program execution. Tokenization. Tokenization, also known as lexical analysis, is the first phase of the compiler. In this stage, the source code is scanned character by character and divided into smaller units called tokens. The lexical analyzer identifies different categories of token, including keywords, identifiers, operators, etc. It is based on concepts from automata theory. The output of lexical analysis is called token stream. Abstract syntax tree. An abstract syntax tree is hierarchical representation of the program statistic structure. It is generated during syntax analysis and provides a simplified view of the program by removing unnecessary symbols such as parentheses and semicolons. It can be represented as AST where assignment operator is root node and variable x is an child and addition operation forms another child subtree. Control flow graph. A flow graph represents the execution flow of the program. If A greater than B, maximum is equal to A, else maximum is equal to B. The purpose of control flow graph is to show possible execution paths, help detect unreachable code, and it is used in compiler optimization. The applications: program testing, static code analysis, and security vulnerability detection. Data flow graph. Data flow graph represents how data moves through a program. Features: it shows the variable dependencies, tracks value propagation, and helps optimize calculation. Advantages: it eliminates redundant operation, improves performance, and it supports parallel execution analysis. AI assistants use DFGs to detect bugs and support optimization. Code property graph. A code property graph contains AST, CFG, and DGF into one united graph. The purpose is to provide complete program understanding, and it helps in vulnerability detection and helps to perform advanced code analysis. Benefits: better code visualization, security analysis, AI powered code reasoning. Large software companies use CFGs to static analysis and cyber security applications. Connection to automata theory. Automata theory forms the foundation of compiler design. The lexical analyzer uses deterministic finite automata DFA and non-deterministic finite automata NFA to recognize tokens. Context-free grammar. Syntax analysis uses context-free grammar. This grammar helps construct phase tree and ASTs. This automata theory provides the foundation for lexical and system analysis in compilers. Connection Connection to AI code assistants. AI coding assistants such as ChatGPT, GitHub, Claude, and Gemini performs analysis before generating responses. The workflow is source code, tokenization, AST generation, CFG analysis, DFG analysis, AI understanding, and suggestion and correction. The applications are completion, error detection, refactoring suggestion, program explanation. The visualizer demonstrates the same concept used internally by modern AI coding assistant. This HTML code index.html creates a web page that shows the structural representation of a C program. It displays a simple C program inside a formatted using pre-tag. This page performs lexical analysis by listing program tokens such as keywords, identifiers, constants, and operators in a table. It shows abstract syntax tree to represent the program's logic structure and design flow. It also includes a control flow graph section to visualize the execution path of the program. The CSS styling is linked to make the page organized and visibly attractive. CFG shows the execution flow of the program, including if else decision and path followed until the program ends. The DFG shows how data moves between the variables where A and B are used to calculate C and then C is printed. CPG combines AST, CFG, and DFG into a single graph for complete program analysis. These graphs help visualize the program's structure, control flow, and data dependencies. The information is displayed inside the separate HTML using tags for better readability. This CSS code is used to style the HTML page and make it visually attractive. It sets the page front, background color, and margins for a clean appearance. The dot container uses a grid layout to arrange context cards into two columns. The dot card class adds a white background, padding, rounded corners, and shadow effects to each section. Tables are styled with borders, spacing, and colored headers for better readability. The pre tag is given a light background and padding is clearly visible display C code and graph structures. This is the output page of the web-based visualizer for structural representation of the C program. It displays the sample C program and performs lexical analysis, showing tokens such as keywords, identifiers, constants, and operators. The AST represents the hierarchical structure of the program and its statement. The CFG illustrates the execution flow, including decision making and program path. The DFG shows how data moves between the variables and how values are stored in the computations. The CPG combines AST, CFG, and DFG to provide a complete view of the program structure, control flow, and data dependencies. Conclusion: the web based visualizer for structural representation of the C program successfully demonstrates the internal stages of the program analysis used by the compilers and AI coding assistants. The system performs tokenization, generation, abstract syntax tree, and visualizes control flow graphs and identifies the data flow graph and it combines them into simplified code property graph. The visualizer also provides insights into the working principle of modern AI coding assistant, making it an effective education tool for learning compiler construction and program analysis.